Hi there, welcome to another Maths School video. Today we're going to be focused on frequency tables and grouped frequency tables. Okay, relatively straightforward topic. Well, let's just get into it, to be fair. Right, so frequency table is used to record data, and then it can record any type of data, but obviously depending on what the data you have got, or depending on what the table kind of used. And that will make more sense in a second as we kind of go through this, but tally can be kept to make it easier to calculate frequency, so the idea of adding up as you particularly go, but ultimately it might be just as straightforward as kind of just add them basically. But depending on the data is collected will really determine how you can go about this. Now, if data is collected like this, so 20 people recorded their shoe sizes, you see a big long list of numbers, and now the idea is you could just literally count how many 3s you've got, how many 4s you've got, how many 5s you've got, how many 6s you've got, how many 8s you've got. There doesn't seem to be any 7s, and then put them straight into a table. The only issue with that is that the bigger this kind of data gets, the more likely it is you are going to make a mistake, which is where the tally kind of comes into play more than anything else. So there's no specific say you must use a tally chart, unless of course you are told to use a tally chart, but just be very, very careful if this data gets quite big. All right, so in terms of the table, so you need your variables. Your variable tend to be the data that you're capturing. So in this case, it's shoe size on the left-hand side. And then now we've put the tally in here so we can focus on it. But ultimately, really all we're after is the shoe size and how many people fit in that shoe size. All right, so the tally is there to support us. So we'll just go along the data, and I'll use the tally as we go in this case. We're just going to kind of cross them off as we go so we can keep an eye on them as we go. So we've got a 3, we've got a 5. We've got a 6, we've got a 4, we've got an 8, we've got a 6, we've got a 6, we've got a 5, we've got a 3, we've got an 8, we've got a 6, we've got a 4, we've got a 6, we've got a 3, we've got a 6, we've got a 5, we've got a 5, we've got a 4, we've got a 5, and we've got a 6. Okay, so there's our tally chart, all right. Did it very, very quickly. I didn't want to kind of waste your time just watching me do a tally chart. But just to kind of confirm this process, I'm sure you might be already aware of it, but if you're not, when we're doing a tally chart, we put them into basically what we call gates of 5. So when we get to kind of 4, we put a line through it, and each one of these gates represents 5. And it's just an easy way to kind of look at it and then decide how many we're going to, because counting up in 5s is relatively straightforward. So if we had lots and lots of data, we could each quickly go 5, 10, 15, 20, and so on, and it would just make our life easier to kind of count and visualize it. Very, very easy. But of course, we don't have that much data, but there it all is anyway. All right, so it looks like we've got 3 from the first one, so we need to add that in. 3 from the second one. Again, that's a 5 because it's just a complete gate, and that's a 5 and a 2, so it's going to be 7. There are no 7s, and then there are 2 people 8, and that's my frequency table. All right. Like I've mentioned before, all right, this type of data, again, it's a kind of discrete data, so it again fits in a category. I've mentioned before, if you're not quite sure what discrete data is, do some research on it, or maybe look at one of the other videos. But discrete data is where something fits in a specific category. It's got to be one or the other, all right? Again, you might mention shoe sizes as being maybe not discrete, but actually you're not going to get 3.2 shoe size. So it has to fit in a specific one, all right? Even if you're talking about 3.5, even that would be 3, 3.5, 4, 4.5. It still has to fit within a specific one. It doesn't continue all the way through. There are gaps, all right? So this is classed as discrete data, and this has to be this way, all right, for this kind of data, all right? So that's discrete. I suppose the flip side to be with that is that when we're talking about group data, and this is more likely to be when we're talking about something called continuous data. So that's not discrete. Continuous is the idea of something not having gaps in between. So like the like of time, speed, distance, weight, mass. So normally unit of measure where it can't be, it could be anything effectively. Okay, so let's have a look. So continuous data must be grouped, and inequalities are often used to avoid overlaps for the groups, and I'll talk about that in a second when we see the data. All right, so we've got an example of 10 people recording in their heights in centimetres. All right, so they've gone for the nearest centimetre, and you can see them all in there. Relatively quite tall people, I think. So 180 is around about 6 foot, isn't it? Anyway, so 10 people recorded their heights in centimetres. All right, so we're going to put that in a table. Well, the idea of saying, are you 180, 181, 182, 183? Well, this doesn't work, does it? Because they're all kind of very, very different. All right, so if I have had to put them into like a discrete category, then every single one of them would have its own unique place, and it would just say one of every height. Well, that doesn't help. So this is where we've got to group them. All right, so This range that you can see from the table is one I kind of put together, or one that has been put together. And you can choose what that group could be, but try and think about a sensible range, and it might ask you to group them in 10s or 20s or 30s, but if I group these into the nearest 50, then they'll all still probably be in one area between 150 and 200. So that doesn't really help me. So you've got to try and split it up in a group that gives you a bit of information in terms of where the average heights would be, but not so much that it's one of everything, if that makes sense. All right, so let's just explain this notation here. The inequalities are often used. So this is what we're talking about, these here. And I've mentioned it in a number of my other videos, and if you want to have a look at it, you'll see this one, which is in cumulative frequency, about this use of notation. Well, if I had someone who's exactly 165 centimetres, it's a case of where do I put them, all right? Do I put them in this one or in this one? Well, this is where the inequalities kind of come into play, because anything that is exactly 165 will go into this one because it says or equal to, less than or equal to, and that's kind of important. Whereas this one, if it's 165 exactly, well, it doesn't fit within that because it's not or equal to it. So this variety of inequality used here supports the idea of determining where 165 exactly goes. All right, so when we get to this one, which is 180, that one there should fit in this particular one and not this one. All right, so that's where the variable kind of come in. All right, we're going to use the tally chart like we did last time, but as you're seeing the numbers go in, hopefully keep your eye out for this one, because this one should go into this one here. All right, but let's have a go. All right, so let's kind of cross them all off. So 172.3, happy with that, goes in the middle there. 168.7 goes there. 180.5, yeah, up in the bottom one. 175, well, this is another one, isn't it? So where's that going to go? Well, it should fit this one, shouldn't it? In fact, it even mentions it over here. The third group, for example, includes 175, but the fourth group does not. All right, so that one is going to go there, isn't it? Let's just double check. Yep. 177.8 there, 166.6, and then this is the 181 I mentioned, but that should go here. Yep. 164.9, 178.6, and 179 finally there, and that gives us our tally. All right. Of course, it is a frequency table, so they need to be tallied at the end with the actual numbers that the tally kind of comes to. So 12241. All right, and hopefully you can see from that frequency table that gives us a better picture in terms of where most people's heights are, and you can see it kind of gauging around about this area. Between 170 and 180, there's 6 people in that height, so that kind of gives you an idea of the graph. All right, so that's frequency tables. You've got 2 different ones. One is obviously from the first one that you did, which was very much a discrete data, and the second one, which is this group frequency table. And this notation, again, you'll keep seeing it over and over again about use of inequalities to support where certain numbers go when we're talking about continuous data. All right, well, that's it. If you need some practice on that, please visit maths-school.co.uk, where there's a bunch of quizzes and kind of questions and all kind of other stuff. If you did like this video, then like everybody else on YouTube, please share and like below. All right, thank you.